Good morning, boys and girls. Here we have Chapter 8, Lesson 8. We're talking about Solutions of Inequalities. Now, I've done a whole bunch of algebra already this year, so now we're going to look at some inequalities. Inequalities, just for your reminder, are when we have greater than and less than or equal to. That's an inequality. So we're going to be doing that, but we're going to be doing it with algebra. So our objective is I can determine whether a number is a solution to an inequality. Remember, that word solution means does it make the equation true or the inequality true. Let's go ahead and look at this. So again, an inequality is like an equation, but instead of an equal sign, it is comparing two math phrases. That word comparing means that we're looking at two different things and we're trying to say, is it less than or is it greater than? So here we have a couple of examples. I want you to write these in your notebook. A is less than 11. 9 is greater than -4. Now this is new for you. You'll see this less than sign with a line underneath it. That means it is less than or equal to 50. And on this one, x is greater than or equal to 3.2. So that's a new thing for you. Here I have it written out. Well, again, and when it has a line under it, it's less than or equal to, and greater than or equal to. So that's a new sign that you're going to be introduced to, but I think you'll understand why in a second. Okay, so the definition of a solution of an inequality is a value of the variable, meaning the letter, that makes that equation true. So something important to note is that in algebra, when we were doing equal signs, we usually just had one answer for our variable. It was x equals 3 or x equals 5. But here we have inequalities. It can have more than one solution. Take a look at this. X is less than or equal to 7. So any number that is less than or equal to 7 could be a solution. So 3, x equals 3. If I put 3 right here for x, 3 is less than, oh, that was a 3, or equal to 7. Is that true? Yes, that's true. So this could be a possible solution. Another possible solution, x equals -85. Is it less than or equal to 7? Yes. So that's another solution. Could x equal positive, could x equal positive 16? 16 is less than 7 or equal to 7, which is not true. So 16 could not be a solution. But any number that is less than or equal to 7 could be. And again, x could equal 7 because this sign right here means or equal to. Okay? So that's just a tiny little introduction to these inequalities. Why would we use things like inequalities? When I was studying it, one of my favorite reasons was think about if you were to go to Lagoon and you get there and you see the sign that says you have to be 48 inches tall to ride the cannibal, okay? And you have to stand next to the little marker and it tells you how tall you are. Well, that means that anyone that is 48 inches or greater can ride the ride. Because if you're 49 inches tall, you can still ride. If you're 50 inches tall, you can still ride. If you're 68 inches tall, you can still ride the ride. But you have to be at least 48 inches tall to ride. 47 inches? Nope. Doesn't count. Can't ride. But you could be 48 inches, and that's why it has that greater than or equal to sign here. Okay? So that's one of the reasons why we do inequalities is for real life situations where it's a range of numbers. You could be anywhere that's greater than 48 inches and you can ride the ride. Oh, this is a little note from my husband. He was helping me today. So here's our first example. There is a library with books from long ago. All of the books are more than 650 years old. So this inequality, A, is greater than 650, represents A in ages and years of books. So all of them are more than 650 years old. So you're not going to have a book that's only 3 years old. That would be less than 650. So A could not equal 3. Could you have a book that's 1,000 years old? Yes, because that's more than 650. But here what they've asked for us is to determine whether A could equal 678 or can A equal 634. They gave us two solutions, and they want to know, is this one true? Is this one true? Or are they both true, or are they both not solutions? So we're going to use substitution. I'm going to take my original inequality. A is less than 650. I'm going to take my first number and plug it in for A. If I said A equals 678, and then I have greater than 650, sorry, I probably said that backwards in the last one. Is this true? 678 is greater than 650? Yes, it is. So this is a solution. It is one possible solution for the inequality. Now we're going to take the next number. A equals 634. So here's our original inequality from up here. If I plug in 634, make sure I get my sign right, is greater than 650. Is that true? 634 is greater than 650? No, that's not true. So this is not a solution. And that's as simple as it is, boys and girls. It's if you understand your number lines, that really helps out, and we'll use that in in lesson 10 for this chapter. But it's really as simple as that. Is this number greater than, or less than, or equal to? So, here's another example problem. So you'll see a lot of problems like this. Determine whether the given value of the variable is the solution. So A is less than 5. Can A equal 3? Well, all I do here is substitute it in. 3 is less than 5. Is that true? Well, hopefully you just know off the top of your head, but if you need to draw a number line, you can. 3, 4, 5. 3 is less than 5 because it is to the left on the number line. So, yes, this is a solution. And when it says determine whether is a solution, determine if it is a solution, then you need to write solution or not solution. It does not ask you to solve it. It just says, is this a solution? They already solved it. You need to say if they did it correctly or not. Here's an example for you to try. Determine whether the given value of the variable D is a possible solution. So, D is greater than 7.2. Can D equal 4? Go ahead and pause the video and try that on your own. Solution or not a solution? Okay. And let's check your work. All you need to do here is plug in 4 for D. D is greater than 7.2. True or false? That is false. So this is not a solution. Because 4 is not greater than 7.2. 4 is less than 7.2. So when they said D equals 4, they were wrong. Okay. Now, we've been just working with positive numbers, but it is possible to do this with negative numbers, with decimals, with fractions. We did a decimal problem just now. But here is a negative number problem. A is greater than or equal to -6. Can A equal -3? Well, in our mind, we want to say 3 is not greater than 6. So we want to automatically say no, but let's look at it. when I draw my number line, I'm going to put my 0 here. This is my positive numbers. And remember, you can always look up at the top of the classroom and see the number line. And remember, going to the left, we start with -1, and then smaller is -2, and smaller is -3, and smaller is -4, smaller is -5, and barely fit here, the smaller is -6. So if I substitute in -3 is greater than or equal to -6, I'm looking for the number, the smallest number is going to be to the left. And -6 is all the way to the left. And -3 is greater because it is to the right. So when it says -3 is greater than -6, this is true. This is a solution. That's correct. Because -6 is smaller than -3. If you're struggling to picture it, think of if you had -$6. You don't want to owe someone $6. You'd rather owe them just $3. So -$6 is more to or is less than -3 because that is putting you into more debt. I don't know if that was confusing. Sorry, it's early in the morning. But -3 is a possible solution. Okay, go ahead and try this one. These are fractions. There's a couple ways you could do this. You could do it on a number line. The way I'm going to show you is I'm going to switch to common denominators, or you could even draw a picture. So pause the video and decide, is t equals 3/4? Is that a solution to the problem? Okay, so what I'm going to do here is I'm going to use common denominators. I could have done a number line. I'm going to write down a couple of options. I could have drawn it on a number line. Another thing I could have done is I could have done a picture. But I'm going to choose to do common denominators because 2/3 and 3/4 I can easily see my denominator. So that's not going to be too hard for me. So if I'm going to switch colors here. Looking at 2/3 and 3/4. 3/4 is greater than or equal to 2/3. If I switch these to a common denominator and an equivalent fraction, then I'll be able to quickly see by looking at the numerators which one's bigger. So 3/4 and 2/3, my least common multiple for 4 and 3 is in fact 12. So I'm going to switch those over. A common multiple, 4 times 3 is 12, so 3 times 3 is 9/12. And if I switch this to 12, 3 times 4 is 12, so 2 times 4 is 8. So now I have 9/12 is greater than or equal to 8/12. So because now we're looking at 12ths, I just look at the numerator here. Is 9 greater than or equal to 8? And it is. 9/12 is more than 8/12, so this is a solution. I want to warn you, you can't do that without changing to equal denominators. You can't just look at the numerator. You do have to make sure your denominators are the same, or you will make a mistake. In this case, it might have worked out for you, but in most situations, it wouldn't have worked out as well. So make sure you have a common denominator before you compare your numerators. Okay, we have more slides. You will sometimes see examples like this. It's going to ask you to give 2 possible solutions to the inequality. Like I said before, there's many options and many possible solutions to a lot of inequalities. So you just have to give, in this example, 2. You need 2 solutions that are less than 3. E is less than 3. So what are 2 numbers that are less than 3? Well, first of all, e could equal 2, right? 2 is less than 3. Another example and I need to give 2 possible solutions. So e equals 2, that's 1. Oops, that's a weird box. And then my other possible solution, could I put 4? 4 is less than 3. Nope, that's not true. Could I put 17? 17 is less than 3. No, that's not true. What if I make it a -17? Negative 17 is less than positive 3. That is true. So these are just some examples. Could have also done e equals 1. You could have done e equals 1/3, because anything that is a fraction, not a mixed number, is going to be less than a whole number of 3. You could have done e equals 2.5. Still less than 3. Lots of options. You just need to have 2 possible. Okay? So here is your turn to try it. You're going to give 2 possible solutions to p is greater than negative 12. So think of any answer to this possible inequality. What can p equal? Something greater than negative 12. You have 2 options. Now this one, I want you to check it off with me or with the aid, because there's so many possibilities here that I want to see your answer before. I'm not even going to give you the answer in the video because there are too many answers to even try writing down. So once you have this, raise your hand. I'll come check it off and see how you're doing. Okay, so here we have a story problem. In our example, I'm going to show you how to do this story problem. S, right here, represents the score that Johnny has to get on his next CFA to get an A on his report card. A lot of you will come up to me and say, how do I get an A on my report card in math? Or how do I get an A on my report card in reading? Well, Johnny knows that he has to get a 92 or higher in order to get an A on his CFA. An A on his report card. So he has to score higher than a 92%. Give 2 possible scores that Johnny could earn to get an A. So we see here that this is S is greater than or equal to 92%. I am going to list all of the possibilities. I only have to give 2, but I'm going to show you all of them. So Johnny, he could earn a 92. That would be sufficient. If he earns a 92, he's going to pass he's going to get an A. He also could earn a 93%. Johnny could earn 94. He could earn 95. He could earn a 96, a 97. I'm listing all of them again. You only had to do 2. A 98, a 99, a 100, and I'm stopping there because we're talking percentages. He can't earn 101% on this CFA unless there was extra credit, but the story problem doesn't give us that information. Johnny cannot get a 91. If he gets a 91, he's going to get an A- on his report card. That's too low. He needs to score higher than that. So any of these are possible solutions for Johnny. He could get any of those scores. Anything less than 92%, it will not get in the A that he is looking for. But he could get a 92. That's the lowest he could get because we have that S is greater than or equal to 92. So here's your chance to try it. I have $20 to buy myself a new hat. So give 2 possible money amounts that represent how much my hat could cost. Got 20 bucks in my pocket. M is less than or equal to $20. How many dollars could I spend? Give me 2 possible amounts. What's my budget for how much this hat could cost? Okay. So there's a couple of possible solutions. First of all, my hat cannot be a negative number because that is not a reasonable answer. You can't put here that my hat could cost negative $3. No, that doesn't work. But other than that, you could put my hat could cost $16. It could cost $10. It could cost $11. It could cost $12.50. It could cost $3.50. It's a really cheap hat. It could even cost $1. It could cost $20. But could it cost $20.01? No, it can't. That's too much. But it could cost anything less than $20 that's still a positive number. That's something you want to make sure is you didn't put a negative number in this situation, because that doesn't make sense. I would not go to the store and buy a negative dollars hat. It has to be something, a positive number that's $20 or less. Okay? So, hopefully that this lesson was pretty straightforward and that you understood how to find inequalities. If you have any questions, please feel free to ask me. And that's all of the lesson for today. Hope you have a great day of learning.